Hi everyone, in this video we're going to talk about graphing and solving systems of linear equations. If you've watched the video for section 7.1, you've already learned how to graph a single equation, so in this video we're just tying together the pieces of what you already know in order to graph multiple equations on the same coordinate plane. So here's our first example. Graph the following system of equations, find the solution, the coordinates of the intersection point. Alright, so what we're doing, we have two lines here. Each of these equations represents a line, and if you think about what can happen with two lines, alright, there's a chance that they're parallel, right, in which case there would be no point where they intersect, but in many cases the two lines actually will intersect, and if they do, it's going to happen exactly at one point. Okay, so this is what we mean by the solution, where the two lines cross each other. Right? If two lines were parallel, then we would say that there was no solution. Alright, another way of thinking of a solution would be a point which makes the equation true. Right? You've already been exposed to that definition. So a solution for a system would be a single point that makes both equations true. So I think you'll see when we graph these and find the point where the lines cross, we can double check by seeing if that point makes both of these equations true. Alright, so to start, let's work with the first equation. And we do have a couple options for graphing. We could use slope-intercept form, so we could rewrite it to look like y equals mx plus b. We could try to find the intercepts. Okay, the points where it crosses the x-axis and the y-axis, or we could just find any 2 points at all that happen to be on that line. The graph that I'm using here is, it goes up to 10 and then also down to -10, so we want to try to choose numbers that are in that range so that they actually show up on the graph. Alright, so if we try to find, first of all, the intercepts, let's try that way first. Alright, so let's make a little chart of values here. Alright, and when x is 0, we can solve for y, and when y is 0, we can solve for x. Alright, so when x is 0, this equation becomes 3y equals 8. And then dividing both sides by 3, we have y equals 8/3. Alright, when y is 0, then we just end up with that 3y term, that's 0, so we end up with x equals 8. Okay, so graphing those 2 points, 0, 8/3, that's 0, and then 2 and 2/3, so you just want to do your best estimate of where that would be. Okay, so somewhere between 2 and 3, a little bit closer to 3. And then 8, 0, that one we can graph exactly. Alright, and then just draw a line that connects those 2 points. Okay, so that's not perfect, but it's fairly close for our purposes. Alright, the next line. Okay, I could do the same thing. I could look for the intercepts, but in this case I'll do the other method. I'll switch this to y equals mx plus b. Alright, so one thing we can do is subtract 2x to get the y term by itself. So we end up with -y equals -2x plus 9. Alright, and then I want y equals, not -y, so I'm going to divide everything by -1. And I end up with y equals, and then all the signs change. This is going to be positive 2x minus 9. Alright, so we have a y-intercept of -9, that's down here, and then a slope of 2, so I would go up 2 over 1, and I'm going to do that a couple times to find a couple points. Maybe I'll even get lucky and see where it crosses the other line. Alright, that's a good candidate right there, etc., etc. Alright, and then draw a line through those points. And there we have it. Another good thing to do would be to label the equations along with each line in case you need to go back and refer to which one is which. So this one is y equals, and actually maybe I'll write the original equation. So this is 2x minus y equals 9. Okay, and then this one is x plus 3y equals 8. You could also color code them if you wanted. That would have been a good idea. Alright, so how do we find the solution, the point where those two lines intersect? Well, I have a good guess based on the graph, and I think maybe it's this point here. Okay, and if you look for the coordinates, that would be 5, 1. Right. But there's always a chance that it's some weird fraction or something that's really close to 5, 1, but not exactly that. So we do need to check and make sure that this is correct. So here's what we want to do. We want to substitute this point into both equations for x and y and see if it makes both of them true. If it does make the equation true, then that means that that point is on the line. So in the first one, to check this one, I would have 5 substituted for x, 1 in place of y, and then we see that that does equal 8. And in the second one, we have 2 times 5 minus 1. Okay, 10 minus 1 is 9. So that checks out as well. All right, so that is the solution to the system of equations. Okay, here's another one. We have some decimals here on the right. All right, so same idea. All right, you can choose to either use intercepts or points, or use y equals mx plus b. All right, so I'll try y equals mx plus b in this case. So the first one, I would subtract 3x, get negative 3x plus 17.5, and then divide by 5. So we get negative 3/5 x plus 3.5. Okay, so I can plot that point, or that line. The y-intercept is 3.5. There it is. All right, and then the slope is negative 3/5. So go down 3. That's going to be right about here. And then over 5. And that lands me right about here. Okay, draw a line through those points. And there's the first line. All right, I'll label that one. That's the 3x. Here's another thing you can do to label. Okay, I might call this, like, I'll put a star by it. That's equation a star, and then I can just put a star by the line, the graph of the line that goes with that. All right, second one. Maybe I'll color code this. So I'll do like a green star or something. So same thing, I can change this to y equals mx plus b form. So first I'll subtract 4x, and then divide by negative 6, and I get 4/6 x, which is 2/3 x. Okay, and then negative 7.7 divided by 6, or negative 6, is 283 repeating. And since we're just looking for a graph here, I'm not going to worry too much about the fact that this isn't an exact decimal or a fraction. Okay. If you're asked for the equation of the line, then we'd probably want to find something a little bit better to represent it than a repeating decimal like this. Okay, so that's good enough for graphing. So 1.283, etc. That's about here. Let's see, 1. Okay, somewhere in there. And then the slope is 2/3, so I need to go up 2 and then over 3, and that's about here. All right, so what do you think the solution is? And let me put a star by this one. So we need the coordinates of the point where these two lines intersect. Right? Well, from this one, I don't know that it's really obvious what the solution is. All right, so we're looking for, this point. but it looks like maybe it's a decimal or some sort of a fraction, or there's the possibility that maybe I just didn't graph this accurately enough and that it actually is a whole numbered solution. So in situations like this where you can't guess from the graph what the solution is, that's why we need an algebraic method to figure it out. Alright, so in the next video I will discuss with you solving a system of equations like this using two methods in order to find that exact point where the two lines intersect.